Hello and welcome. Special effects. Hello, today's compound is a pleasant one. It finds uses in the flavor and perfume industry. It has a pleasant aroma of honey and cinnamon. As well as a fragrance, it is chemically aromatic due to it containing a benzene ring. More specifically, delocalized conjugated pi electron system, fulfilling Huckel's rule for chemical aromaticity. Huckel. A compound is considered aromatic if it meets the following four conditions. It must be cyclic, as in it must have a ring structure. It must be planar. Every atom must be on the same plane. For effective p orbital overlap, it must be fully conjugated, p orbital on every atom. The number of pi electrons must be 4n plus 2, where n is any non-negative integer. Our compound consists of a phenyl group at one end, which is benzene when it's minus a hydrogen and bonded to something, and a carboxylic acid group at the other end, defined by a carbonyl group next to a hydroxyl group. These phenyl and carboxylic acid groups are joined together via a carbon-carbon double bond, which makes this an unsaturated aromatic carboxylic acid. If you haven't guessed already, it's cinnamic acid. The old way of making this was via the Perkin reaction, described in 1877. This method consisted of heating benzaldehyde with acetic anhydride in the presence of an alkali salt like sodium acetate. The disadvantage of this method is that it requires higher temperatures, longer reaction times, and it's non-stereoselective, and it has a tendency for unwanted side reactions, resulting in lower yield. Later came another method involving diethyl malonate and the weak base piperidine. The base deprotonates the active methylene group of diethyl malonate to form a carbanion, which then undergoes a nucleophilic addition to the aldehyde's carbonyl group, followed by the elimination of water, condensation, to form an alpha-beta unsaturated diester intermediate, diethyl benzaldehyde malonate. At the turn of the century, Verley-Doebner introduced the use of malonic acid instead of diethyl malonate. The hydroxyl group in malonic acid is a better leaving group when protonated compared to the ethoxy group of the ester, diethyl malonate. The carbonyl carbon of malonic acid is susceptible to nucleophilic attack. With piperidine as the catalyst and pyridine as the solvent. The procedure proved to be highly efficient at producing alpha-beta unsaturated carboxylic acids. Albert Verley introduced beta-alanine as an alternative for the more toxic piperidine. The beta-alanine and pyridine both act as catalysts. Pyridine is a base and a solvent, where beta-alanine, a primary amine, is a stronger base. The base deprotonates malonic acid to form a nucleophilic enolate carbanion intermediate. The condensation. The nucleophilic malonic acid intermediate attacks the carbonyl carbon of benzaldehyde. This is an aldol-type condensation, the elimination of water, which is facilitated by the heat and the base, forming an alpha-beta unsaturated dicarboxylic acid intermediate. Finally, there is a decarboxylation. Today's practical demonstration is cinnamic acid via the Verley-Doebner modification of the Knoevenagel condensation. Verley-Doebner modification of the Knoevenagel condensation. The product of this reaction is most certainly cinnamic acid, 3-phenylpropanoic acid. Here I had to leave this to reflux for 2 to 3 hours. As this is a one-pot synthesis, all I have to do after this is the workup. The nucleophilic attack, the dehydration, the decarboxylation, all happens in the one flask during this 2 hours. A fairly pure product has formed. I will leave you with the filtering and the washing steps, and some music.